All right, here we go. Okay, let me get your attention up here, please. Okay, so last day of review for here's how it's going to go. We're going to start the computer adaptive test part tomorrow. Okay, that's the stuff that's the regular part of the test, part we've been practicing. We'll go to 205 tomorrow. I'll be with you in there Tuesday, Wednesday, possibly Thursday. And then Friday, I'll be gone at a track meet, but you guys will have an opportunity to keep working on that if you need to. If you don't, that's fine. Then you'll just have time to work on other stuff. You can just use Chromebooks and work on other assignments. You're not going to start on the performance task part until next week, though. Even if you finish the first part, you're not going to go on. We're just going to do the CAT part, and then next Monday we're going to do a brief review for the performance task part, where I'm just going to put up a practice problem, and we're just going to go through a solution together. We're not going to worry about the math part. I just want to practice how would you answer the questions in order to get the most points. Okay.
What's the format of the test? What's the first part?
So the first part is kind of like the multiple. It's not all multiple choice. I mean, there's going to be some stuff where you use the tools to create a line, or you fill in maybe you have to give a number answer for one. Choose all that apply. I mean, it's stuff like we've been going through in class. Those are good sample problems for the first part of the test. Okay. Last thing I want to do though. So for today we're going to go through the just one last little type of problem. These are rational equations where you can't just cross multiply. Okay, it's not a big deal, and I've got some practice assignments up there. Let me just show you real quick what this looks like. So if I went to the Algebra 2 page, here's what you'd see. If you go down to the SBAC review, if you click on the SBAC review block, okay, everybody should be turning around facing up here. So you won't see this stuff, but here's all if you click on this one, it'll pull up my YouTube playlist, and here's all the review sessions we did in class for the SBAC. You can look at those, okay? Okay, hey listen, last day, don't get distracted. Let's see, get rid of that. If you want to do a practice test, I've included, here's the notes for me every day except one. One of them I deleted accidentally. The practice test, here's a full practice test you can take. If you click on that, it's going to open up a full test. It's broken up by topic. I would encourage you to go through that tonight. I've got a little bit of additional rational functions practice. If you click on that one, it'll just pull up a very short assignment with this kind of stuff that we're doing right now. It's only got 6 problems. I would just do 1, 3, and 5, and then go back and do 2, 4, and 6 for extra practice if you want it, kind of a thing. I'll put up another short one right after school. I'll put up another one on trig practice. But otherwise, I think there's enough stuff built in there that you're fine. So get to bed early tonight, eat a good breakfast tomorrow, have something good for lunch. You'll be fine. All right, so let's do a little practice here. So what do we do with these? Now here's our strategy. So everybody pay close attention here, especially at the beginnings. I'm going to tell you this is how we approach these things. So let's get rid of any distractions. Please get rid of those. So we're going to do 2 things. We want to get everything. We're going to set the whole thing equal to 0, and then we want to write everything that's on one side of the equation that's not the 0 side, but the other side. We want to write all of that as a single fraction by getting a common denominator. Okay, and then we'll do 2 things with that answer. So first things first, let's go ahead and add this term to the other side. Now when I have a term like this, if I have a negative sign up top, where can a negative sign go for a fraction? There's 2 legitimate places to put it. You can put it in front of the fraction, or you can put it in the numerator, right? Let's take this one and let's just move it down there so it's out in front. Okay? If we do that, what do we end up getting then? If I move everything over to the left side, I'm going to have on the left side, I'm going to have a negative 13 over 6x minus 13/12, and then I'm going to add this term to the other side, so plus 13 over 3x equals 0, right? Everybody agree? Okay, so then what we want to do is we want to get a common denominator on the left side. So I'm going to take each of those terms and I'm going to leave a little space for us to multiply the top and bottom by something to get a common denominator. So the first term is negative 13 over 6x. Second term minus 13 over 12 times something over something if we need it, plus 13 over 3x times something over something equals 0. So let's get a common denominator. Let's think of it in two parts. Let's think of the number part here first. What's the smallest number that 6 and 12 and 3 divide into? 12. Good, 12. So we want to get a 12 on the bottom, right? So what am I going to multiply this first fraction by, top and bottom, to get a 12 on the bottom? So 2 over 2, right? This one I've already got a 12, right? This one here I'd multiply by 4 over 4. Okay, now look what that gives me. This whole part right there is going to be 12x, right? This whole part right there, everything on the bottom, when I multiply it out, I get 12x. Here, I've only got a 12, so I need the variable part also, right? I need to know what's the smallest power of x that I could have in the denominator, so each term divides into it. And the secret is it's always just going to be on the bottom, whatever the largest power of x in the denominator is, that's what I need in my common denominator. So in this case, it's just a plain old x. So what do I need to multiply this one by, top and bottom? X. Good, and now notice what I've got. Now I've got my common denominator, right? So this next step is really not necessary, but I'm going to write it out anyway. In the future, you could probably skip this. But this first term, if I write this then as, if I clean up this fraction, I'm going to get 12x on the bottom, and on the top I'm going to have what? If I multiply straight across like I do with fractions. Negative 26, good. And then I'm going to do, over here I'm going to do, it looks like, I tell you what, well, either way. We can either put the minus sign there, or I could put plus negative 13x. Either way. Over 12x, right? Everybody agree? Plus 13 times 4, what's that? 50, I heard 52 over 12x equals 0. Okay, the reason I said that step maybe wasn't necessary is because, look, I've got a common denominator, so I could write this as one big fraction, right, with 12x on the bottom. That's my common denominator, right? So we could write this whole thing as some stuff over 12x equals 0. Well, what goes on the top? Here's my common denominator, so the top has to include everything that's being added and subtracted all the way across the top, right? So let's just combine those like terms. So I get negative 26 minus 13x plus 52. So that leaves me with a negative 13x is my x term. Negative 26 plus 52 is what?
26.
Plus 26. Okay, so then look, we accomplished it now. Look what we just did. So we got this whole thing. That's pretty good, right? We got this whole equation written as one fraction being equal to 0. Okay? So let's come back over here and look at this then. So we got to be careful about this. Now notice I've got an x on the bottom here, right? So I have to ask myself, what are all the values of x that would make the bottom equal to 0?
0.
Well, 12 times what would give me 0?
0.
0. Okay, so that tells me that x cannot equal 0 because that would make the bottom, that's a 0 of the denominator, right? And if you look at the question, there's two parts to it. First part says x values that must be excluded are what? If multiple values exist, separate them with commas. So the only one we have to exclude is 0, okay? Now think about, so the bottom is important for that reason. The denominator of our fraction tells us all the values of x we have to exclude, okay? Well, when is a fraction equal to 0? I'll give you an example. Tell me which of these fractions, I'm going to write 3 of them down here. Tell me which of these fractions are equal to 0.
Middle one.
The middle one, right? So a fraction equals 0 when the numerator equals 0, right? Everybody agree? Okay, so then we're just going to answer the question. If we want to know what the solutions are to the equation, when does the fraction equal 0? All we have to do is take the numerator of our one big fraction and set it equal to 0 and solve, right? So we end up with the equation negative 13x plus 26 equals 0. So what are the two steps in order to isolate x? Subtract 26. So negative 13x equals negative 26. Divide by negative 13, and x would equal positive 2, wouldn't it? Okay? So 2 is the solution. So that's what goes in here. Now I do have to always check and make sure that my solution is not also a value that's excluded, because if it is, it doesn't count. Then it's not a solution. Okay? So in this case, the solution, the single solution is x equals 2, and there's one value of x that we can't have in our domain. That's x equals 0. Okay? All right. Say it again.
How do we know the multiple value?
We'll see one like that right now. So let's look at another one. Same kind of problem. Okay, we'll look at this one now. So first of all, let's look at this quadratic expression in the denominator. And let's see if we can write it in factored form. So are there magic numbers that multiply to 18 and add to 9? 6 and 3. Yeah. So this breaks up into x plus 3 times x plus 6. Well, notice that those two factors are the same factors that show up in the denominators of the other fractions, right? So I could even answer this first question right now if I want to. I don't have to wait until the end. I could do it right now. If I look at these fractions, Kaylin, what's going to be the value that x cannot be to make so the bottom is not 0? What value would make that denominator 0? Negative 3. So x cannot equal negative 3 because it makes that one 0, right? So we can add that to our list right now. What's the value, Willie, that's going to make that denominator 0? Negative 6. So x cannot equal negative 6. And then aren't those the same two values that would be the zeros of that denominator also? If I set it equal to 0, wouldn't the bottom equal 0 when either x is negative 3 or negative 6? Everybody agree? So we have two values, multiple values this time, two values that we have to exclude. Okay, so now next issue. So now let's go ahead and turn this all into one big fraction. So we have an option. We could either subtract this whole thing to that side, or we could add each of those terms to the other side, right? Let's go ahead and move. I'm going to take the being as, not that it makes really that much difference. Either way is about the same difficulty. But being as I've got two parts in the numerator here, each of these only has one part, I'm going to go ahead and move these to the other side. Okay? So let's move that negative down there so it's in front. So if I move everything over to the right side, we've already got this term on the right side, right? Oh, Sarah, you already got mine?
Yeah.
Okay, thanks. So then this guy is already over on the right side, so let's put it down there. X squared minus 21 over, and I want to write it in factored form. Right? I want to write it in the form x plus 3 times x plus 6. And you can probably already maybe see why we want to have that in factored form. Now what about this guy here? I have a negative 8 over x plus 3, so I've got to add that to the other side to get rid of it. Agreed? So we'll add to this 8 over x plus 3. And here I've got another negative term, right? So let's add 5 over x plus 6. Everybody agree? Okay. I'm going to leave a little space in there. And then what am I left with on the other side when I get rid of those?
0.
I've got 0. I'm going to flip it around so the 0's on the right instead of the left. Same difference though, right? Okay, so now, what do you think my common denominator is going to be here on the bottom?
6.
What's the smallest thing that x plus 3 and x plus 6 will divide into? X plus 3 times x plus 6, right? Won't they divide into the product?
Yeah.
See what I'm saying? So then, think of it this way then. What would I need to multiply the bottom by here to get my common denominator? Right? I've already got an x plus 3 times an x plus 6 there. No,
X plus 6.
x plus 6.
Yeah, and on the other
See what I'm saying?
X plus 6.
And then this one's going to be, I'm going to multiply the top and the bottom by x plus 3. And the reason I'm doing that is, well, look what I get now. I get the same denominator everywhere, so that's my common denominator. See what I'm saying? Okay, the denominator is just built from the two factors, x plus 3 and x plus 6. I need the product of those two. I already had that here, so it's done. This one I only had the x plus 3, so to make it the same as this one, I got to multiply top and bottom by x plus 6. This one I already had the x plus 6, so I need to multiply by the quantity x plus 3. Okay? You might be thinking that's pretty contrived, that it works out. Well, it is, but those are the, you're not going to get anything harder than that, right? So you can expect to have that kind of a situation where the factors are all going to show up. I mean, this would be pretty hard to do if this thing didn't factor into x plus 3 and x plus 6, right? That's a kind of a calculus or pre-calculus level problem. This is what we do in Algebra 2, maybe, okay? So now let's skip the step where we write all this stuff out as 3 terms. We already know we're going to get a common denominator here of x plus 3 times x plus 6, right? So let's put everything on the left side over my one common denominator, x plus 3 times x plus 6, and then we'll just add up the top, right? Because we just want to find out what's the sum of all that stuff, because that's what we're going to set equal to 0, right? We've got the same denominator in each fraction, so let's just combine the numerators. Let's just do this term by term. So the first one's just going to give us plain old x squared minus 21, right? What about the second one? Well, if I distribute the 8, what's that going to give me? Okay, does that make sense? Okay, what about the last one then? If I distribute the 5,
5x plus 15.
right? And then that whole thing is just equal to 0, right? So we already, the bottom, we've already taken care of. We already know that the values of x we can't have are -3 and -6. We could have done it here also though, right? We could have looked at this and said, okay, well the factors on the bottom, I can see I can't have a -3 and a -6. Already taken care of though, right? What about the solutions? Well, we just have to combine this into one real simple expression and set it equal to 0 and solve. Okay, so what are we going to get if I combine like terms? So I've got 1x squared. How many x's? Plus 8x plus 5x. Okay. Minus 21 plus 48 would be, what is that, 27 plus 15, 42. And then I'm setting that whole thing, right? I'm just going to set that whole thing equal to 0, right? Because the fraction equals 0 when the top equals 0. So when does the top equal 0? Well, let's solve that. Are there magic numbers?
No.
Wait.
I mean, I can always use the quadratic formula if I need to. But let's look for magic numbers.
Add the what?
Yeah, we got to multiply, yeah, add to 13 and multiply to, there you go, 6 and 7. We got to multiply to 42 and add to 13, right? So we get x plus 6 times x plus 7. So what are my solutions going to be?
-6, -7, but you can't have a -6.
Aha, there you go. So those are my solutions, but remember, we can't have -6, right?
Boundary -7.
So we got to come down here and cross that one off, and we only get to keep one of them, which is -7.
So that's
That's the only solution we get, right, is -7. Okay, let's do one more, and then I'm done. You can practice this stuff a little bit, and we'll call her good. Okay, so what about this one? Let's go ahead and push everything to, I don't care, let's push everything, as this has got 2 terms on the top. Let's just take these terms and push them over to the left, okay? So we got x minus 4 over x minus 6, and then let's put that negative out front. So what am I going to have to add to the other side to get rid of this one?
plus 3.
Yeah, right. 5 over x minus 3, right? Now if I want to, I can leave the negative on top, it's fine. If I want to, I could just subtract this whole thing to the other side, it's fine. If I subtract the fraction -5 over x minus 3, though, subtracting a negative is just going to be adding, isn't it? Either way, I do want to scoot that over and leave myself a little bit of extra room. Oh, what happened there? Guy got left behind. I do want to scoot this over and leave myself a little bit of room, though, so I can get a common denominator, right? Okay, so that term got added over there, and then we're going to subtract this one to the other side also. So we're subtracting the 6 over, now what's that factor into? Let's go ahead and factor this. What are numbers that multiply to positive 18 and add to -9? -6 and -3. So what's my common denominator going to be? What's the smallest thing that all 3 of those factors would divide into? Wouldn't it just be the product of the 2, right? Okay, so what do I have to multiply the first one by to get my common denominator? Aha, x minus 3, top and bottom, right? Right, everybody agree?
Yeah.
Now I've got the same denominator as I have there. What about this guy here?
Multiply by x minus 6.
Right? Okay, now look, I've got common denominators. There, there, there. So I'll write it as one big denominator, right? So what values do I have to add to my exclusion list? What values of x do we have to exclude?
6 and 3.
6 and 3, right? So I'll come up here and I'll say x can't be 6 and it can't be 3, okay? What about the numerator? Well, we got to figure out what we get. So now, from this term, I'm going to have to multiply that out. So let's do that. Let's be careful and do that. If I distribute the x times x is x times -3, -3x, but I'm also going to distribute the -4. So -4 times x, -4x. Well, let's combine those. -3x and -4x is what? -7x. Okay, so we can just combine those into one term. And then finally, -4 times -3. So there's what I get from the first term, right? Okay, now minus a negative, we could make that a plus 5, and I got to distribute the 5. So 5 times x, 5 times -6. Okay, good. And then over here, I've just got a -6, right? That make sense? So here's from that, and there's from that, right? And it's all equal to 0. Well, when does a fraction equal 0? You're right, numerator, when the numerator equals 0. So we'll just set all the whole blue numerator, we'll simplify and set equal to 0, right? And what do we get? So I've got 1x squared term. Let's add up the x's. Negative 7x plus 5x. Negative 2x. So positive 12 minus 30 is negative 18 minus 6. Negative 24. And the whole thing is equal to, is equal to 0, right? So what does that factor into? Say it again. It's got to multiply the negative 24 and add to negative 2. Okay, x minus 6 plus 4. So what are my solutions then? Either x equals 6 or x equals negative 4, but it can't equal 6, can it? Right? So no, there is. Negative 4 works, but we had to cancel that one, right? Okay, so we do get one solution. My solution is negative 4. Okay, make sense?
Yeah.
Okay, last thing. I want to show you, no, real quick, I want to show you one thing. This is it. Okay, look right here, real quick. I just forgot to show you this the other day. It's so simple. I know, I'm done. I'm done for a week. Okay, so what if we want to find the measure? It's SOHCAHTOA, right? I want to just show you one little trick here. So what's going to be the relationship here? If we're talking about angle y, well, that's angle y. So from the perspective of angle y, this is just SOHCAHTOA stuff, right? If that's angle y, which side is the hypotenuse?
The 14.
The 14. So that's going to be the h. What is this side right here from the perspective of y? Opposite. So what's going to be the SOHCAHTOA function then that connects y to those two numbers? It's going to be sine, isn't it? Sine is, because it's SOH, S-O-H. Sine is opposite over hypotenuse. So that tells us sine of y equals 9 over 14. Okay, last step. Last step. So simple here. So then, if we want to solve for y, here's the trick. If I want to isolate the y, I've got to get it out of the sine function. So here's how you do that. The way you unlock a sine, how do you unlock a cube function? I cube root it, right? How do I unlock a squared function? I square root it, right? So I have to do whatever operation is required to undo what was being done to the variable, right? So here what's being done to it is sine. How do you undo a sine function? You do an inverse sine. I'm going to do the inverse sine of both sides. So the purpose of an inverse sine is what unlocks a sine. It cancels the sine, just like a cube root cancels a cube function. And so that gives us over here plain old y equals, and on this side, I just get back whatever my calculator tells me that is. The inverse sine of 9/14. And if I plug it in on Desmos, here's what I get. Okay, so let's try that real quick. If I plug in, whoops. Now I know this has been a lot of review, and you guys have done a great job, but just don't give up yet. I got literally like 10 more seconds. Okay, somehow muster the strength to just look at this one last thing here, right? So all I've got to do, everybody with me? Willie, turn around, please. So if I want to solve for y there, I just have to put in whatever the arc sine or the inverse sine, people sometimes call it an arc sine, of 9/14. Where am I going to find that? Well, I've just got to go down and, oops, I just have to go down to the bottom, and I'm going to look under functions, and it's right there, isn't it? Okay, I'm looking out there, and I'm seeing a lot of people. I'm only seeing about 4 people that are looking up here. Okay, this is like, I know this is a lot, but this is the last little thing, and this is a great trick that might show up. There's the inverse sine part, right? So inverse sine of what? 9/14. 9 over 14, right? So all I got to do then in here is just put 9 divided by 14, and it gives me back that. Okay?
So you type in 0.7, that'd be the answer.
So yeah, it is. But hold on, one last thing. So now this will be, I need to put it in degrees. Yours will be in degrees. This wasn't the SBAC one. But if I put it into degrees, it tells me that's what the angle is. Doesn't that make sense? So it's about 40 degrees. Okay? That'd be the answer. That's right. Find the measure to the nearest degree, 40 degrees. Okay?
Why could we just type in SIN square, like square